Today, we're going to be talking about binary search, which is the fastest of the search algorithms and most efficient. So as we look here, we see that binary search has a runtime of O log of n. Also, to implement a binary search, our list has to be sorted. It also uses the divide and conquer technique. It works by repeatedly dividing in half the portion of the list that could contain the item until you've narrowed down the possible location to just one. As we look in this diagram we have here that I found online, computerhope.com, it shows kind of how the implementation is working. As we see, our key here is 9, which will be our target in our implementation of our live coding later. And then we see that 9 is greater than 7, so then we choose the right-hand side, and then we see that 11 is now greater than 9, and then we choose the left-hand side of our array. And then in step 3, we find our location. So basically, what we're doing here is we're narrowing down where our target is at. And that is how binary search works. It's great, it's fast, and it's very efficient. So here we're going to be implementing our binary search. So we have our array and our target. Here we have our test array. So 1, 2, 3, 4, 5, 90, and 120. And our target to get is 120. So let's get started. So first, we're going to have to get our low and our high of our array, of our list. So low equals 0, and high is going to be the length of our array minus 1, which puts us on the right-hand side of our list. And then we're going to use a while loop. So while high is greater than or equal to low, this is going to continue to iterate as long as that condition is being met. That's how a while loop works. Then we're going to have to try to find the middle of our list. So middle is going to equal high plus low using 2 of these divided by 2. If we use only one of these division symbols here, it would actually possibly give us a float, but we want to have an integer, so we're going to use 2. So next, we're going to check if the item is equal to the midpoint, and if it is, we're just going to return back that position. So if array middle is equal to our target, we're just going to return middle. So then we need to check, the next check is going to be if our item is to the left of the middle. So let's go ahead and try that. So elif, our target, if our array middle is greater than our target. So that's going to be, if it's greater, then it's going to be to the left. So we're going to basically now make our high equal the middle minus 1. And what's that doing is now the element would be directly left to the midpoint. Next, we're going to check if the item is greater than the midpoint. And if that is true, we only need to check items to the right. So we're just going to do an else statement, and then we're going to do low equals middle plus 1. And in our loop still, in our while loop, if the item isn't there, we're just going to go ahead and return none. So let's see if this works. Let's run it. And it says 6. And that is correct. So that is how you implement a binary search. Thanks so much.